Okay, this is our last problem. So we're going to find the max, the min interval of increase and decreasing of this rational function. And if you see a picture, like I said, for this lesson, you're seeing the graphs, but usually you will not. But just looking at this function, I know that there's probably going to be an undefined value because I have a variable in the denominator. So I just keep in mind, anytime I want relative max, relative min, intervals of increase and decreasing to find those critical values, your first derivative has to equal 0 and your first derivative can be undefined. So regardless, we have to start by finding the first derivative. The only way to take the first derivative of a rational function when you have a variable in the numerator and the denominator is to use the quotient rule. So at this point, I really would encourage you to start trying to say it out loud and kind of sway away from using that key, because as you see, this is now going to be where the first derivative is just part of the question, not the actual question, and you need to get comfortable and fluid with that process. So here we go. The first derivative of a quotient rule is the derivative of the first, so you get 2x times the second minus the derivative of the second, which requires the chain rule. 3 times, this stays the same, drops by 1, derivative of the inside, times the first, all over the second function squared. So now we clean this up. Okay, I'm going to GCF, the first derivative. What I can pull out, and I'm purposely not going to pull out an x even though I know there's an x in both terms. I'm going to pull out the x minus 4 because x minus 4 binomial is in both terms, and I'm going to take out the smaller of the two exponents, so it's squared. So then what I'm left with is 2x, and this drops down to just 1. And then here, this would go away completely because that x minus 4 squared would cancel out, come out, and you'd be left with minus 3x squared. And you'd have to continue to clean up this top, and you would get 2x squared minus 8x minus 3x squared. So in the numerator, I'm just going to rewrite that. You're going to get x minus 4 squared, and when you combine like terms, you're going to get negative x squared minus 8x, and on the bottom, you get this, the second function squared, you get x minus 4, a power raised to a power is to the 6th power. So I'm looking at this and I go, well, I can clean this up. This can cancel out and drop this to 4. So the first derivative is equal to negative x squared minus 8x over x minus 4 to the 4th. So there is my first derivative. And now what you want to do is find the critical values with the first derivative being undefined and the first derivative being equal to 0. I'll start with the first derivative undefined. Well, that is going to happen here because I have a variable in the denominator. So the only time a function is undefined is when the denominator is equal to 0 in this case. So you're just going to take x minus 4 and say what value of x will make that expression equal to 0. I take the 4th root, and you're allowed to take the 4th root of 0, and you get x minus 4 equals 0. I add 4, x equals 4. And x equals 4 is a critical value that came from the first derivative being undefined. I'm going to put that on my first derivative number line. I'm going to put a 4 here, and I'm just going to do a dotted line so I know that that was from the first derivative being undefined. Looks like an asymptote. Okay, the next time is to see about the first derivative equaling 0. So in that case, I'm going to take this negative x squared minus 8x over x minus 4 to the 4th equal to 0. And you might know that the only way a rational function is equal to 0 is when the numerator equals to 0, or you can organically figure that out by cross multiplying and getting negative x squared minus 8x times 1 is equal to 0 times this. It just turns into 0. To solve that, you're going to GCF a negative x out, and you're left with x plus 8 equals 0. And then we get that you set each factor equal to 0. And your two critical values that come from that is negative 8 and 0. So those are my values, my critical values. So I need to now perform the sign test to decide if there's plus, minus, what values go in there. All right, when you perform the sign test, you want to perform it into the first derivative, but only when it's in its factored form. So right here, this right here is our first derivative function. I want you to make sure it's in factored form, which it's not. I'm going to rewrite it as the first derivative is equal to negative x plus 8 over x minus 4 to the fourth. And now I'm going to test and see what h prime of negative 9 would give me value-wise. H prime of, let's go, negative 1, because I'm going to pick a number there. And I'm going to pick a number at h prime of 1 and h prime of 5. That's going to take care of all these sections. I got 1, 2, 3, 4 sections to decide signs. So when I go ahead and plug this in, I'm plugging this value into the factored form. A negative 9 plugged into this is going to, negative times negative 9 is a positive. A negative 9 plus 1, negative 9 plus 8 is a negative. And then it doesn't matter what value I get in. When I raise it to the fourth power, it's always going to be positive. So a negative over a positive is a negative. So I know this section right here is minus. Now, the next one, when I plug in negative 1, a negative is a positive. Negative 1 plus 8 is a positive. Always over a positive. And that's going to give me a positive in that section. So this here is positive from negative 8 to 0. When I plug in 1, a negative times 1 is a negative. A 1 plus 9 plus 8 is a positive. And this is always going to be positive. That's going to give me a negative value here. And then 5, when you plug in 5 to here, you get a negative times a positive and always a positive. Well, that's going to be, hold on a second. You plug in 1, you get, and when you plug in a positive 5, you're going to get value after that. You're going to get a negative. Okay, so now I see that this is a negative. So if I'm looking here, I see that this is going to be decrease to increase. So if I have a decrease to increase, well, now I know I have a minimum at negative 8. And we are going to eventually find the max. So negative 8 is going to be showing that I have some sort of minimum. And then, and that's not captured in this window. If you have a maximum right here at 0, and then my intervals of increase and decrease. My interval of increase is happening wherever I see that this function is positive. So it's from negative 8 to 0. And that's it. So from negative 8 to 0, this original function is increasing. Okay, I had a little bit of a pause. Sorry about that. But negative 8, as we said, we left off, is a minimum and a max at 0. Now, if you're looking at the graph as I am, you might see negative 8, 1, 2, 3, 4, 5, 6, 7, right here, and you see 0 here. And in your head, you might say, that doesn't look like a minimum or a maximum, but in reality, this window is just what you would see in your calculator with a negative 10 to 10 window frame, where you would have to manipulate the graph and zoom in so that you could see that slight change. That's why using derivatives to find max and min is a more effective way than just trying to see it on a graph. So that being said, once you've done all this work, the last piece is to find the actual y coordinate of the min, and you do that by taking that value and plugging it into the original. So in this case, I would take negative 8, I would square it, and then plug in negative 8 for x here, minus 4. And if you're not sure what I'm doing, I'm literally taking that negative 8 and plugging it into this function, the original function, and you end up getting 64 over negative 12 cubed, which reduced gives you negative 1 over 27. And then when you plug in 0, when I go ahead and plug in 0 here, I'm going to get 0 squared over 0 minus 4 cubed. I'm just going to get 0. So that's my max. My interval of increase I left off by saying was from negative 8 to 0. And then I had two intervals of decrease. Interval of decrease is going to be from negative infinity to negative 8, and from 0. Now you have, because there is an asymptote at 4, you can't just say from 0 to infinity. You have to say from 0 to 4, and then from 4 to infinity. Okay, now I know today's lesson was tough. We are making our next mandatory our next Google Meet mandatory, so please look on Google Classroom for when that's happening. If you have any issues, please email us. Thank you very much.